The broadcast is now starting. All attendees are in listen-only mode.
Good morning. This is Jeremy Henick from Isograph. Thank you for attending today's webinar. I just wanted to go through a few things today before we get started. Today on the phone we have myself and Joe Belland. Probably most of you are Isograph clients. You know Joe. Joe is head of our technical support and does our training for North America. I do the business development for the Isograph team. So the main purpose of today's webinar was to just go through upgrades that have been added to Reliability Workbench version 13. As you know, we usually release minor upgrades to the software over the year, and then when we have enough minor upgrades to constitute a major upgrade's released. So with the major upgrade, you'll need to upgrade your licensing as well. Rather than go through all of this list, what I have done is I've added a handout to the web meeting. In the right-hand browser window, you'll see an option for handout. If you open that, there's a PDF called RWB-Release 13. This will give you a list of the additions we've made to the Reliability Workbench version 13 and give you some descriptions on each of them. It'll also give you a bit of information on licensing, some things that you should know when you upgrade the software. It will be reverse compatible with version 12 and 11 if you're still using 11 by chance. This is just a list. This list is just some of the features you'll see in the release notes. I'm not going to go through them all. I'm going to let Joe do that actually so he can give you examples of each of them. But one thing I did want to mention is training. If there's any of you that are interested in training, although you've already missed the training we did in Newport Beach this March, we'll be having training in Park City, Utah next month, the end of next month. Park City is a great place for training in the summer. It's quite a nice, relaxed environment, and there'll be things to do when you're not training. And then closer to the end of the year, we'll be also having a training in Houston, and not listed in this. One of the days of the fall tree training will be dedicated to the IEC 61508 module failure module in the fault tree software. And then, as you know, you can always get support from Joe, usually via email or phone, but we can also set up web meetings like this if you need them. And all of you probably have my contact information, but there it is. What I'm going to do is hand this over to Joe. Joe, are you ready to get started?
Yes, I am.
Okay, I'm going to make you the presenter, and you should have controls now.
Yeah, let me get the right screen. I have a multi-monitor setup, so I have to make sure I'm showing you the Reliability Workbench and not my my email software on the other screen. Anyway, so I've shared my screen. I hope you can see the Reliability Workbench software.
Oh, Joe, one thing before you get started, I forgot to mention.
Yeah.
In the left hand, everybody's muted because there's quite a few people on the call. In the right hand screen, the pop-out screen where it shows information on the GoToMeeting software, GoToWebinar software, there's a section called Questions. If you have any questions, please post them in that questions dialog, and then Joe will pause throughout the meeting to answer any questions you might have. And if we don't get your question for some reason, we'll contact you after the meeting. Okay, sorry, Joe.
Okay, no problem. That's right. Yeah, Jeremy will be monitoring the questions section. I can't really look at it while I'm demonstrating, but periodically I'll stop and ask him if there's anything he wants me to cover or to answer. Honestly, Jeremy will probably be able to answer most of your questions in the chat, but if there's anything that he thinks of will be of a general interest, then he'll ask me to show it in the software. So anyway, let me just show you some of the new features of Reliability Workbench 13. And we'll start with the prediction, because that's where some of the biggest changes have been made with the prediction modules. Firstly, two big changes. One, the 217 plus standard, and that's the Reliability Information Analysis Centers standard, and also the SN29500, which is a Siemens standard. Both of those have been updated to the latest versions. So there was a version 2015 update to the MIL 217 plus that has now been implemented. As with the SN29500, there's a version or edition 2015-4, which we've now updated. So both of those are now the very, very latest editions of those two reliability prediction standards. So if you're using either of those prediction modules, those prediction standards, you can rest assured that Reliability Workbench is giving the latest calculations based on the latest editions of those standards. Speaking of standards, there's also a new one that was just introduced in Reliability Workbench. It's known as the Fetus standard. The Fetus standard, actually, I looked into this, is actually from I think it's a French standard. It was created by a consortium of several different companies, French companies, and they're trying to, again, this is what a lot of people are doing, they're trying to come up with a replacement, a global replacement for the MIL 217 standard, which is now 20 years old, hasn't been updated. And a lot of people who are dependent upon that are now looking for something that's more accurate. So the Fetus is just the latest standard that's one optional replacement for that MIL 217 plus, or excuse me, the MIL 217 standard. Just a quick note on that. Let me just show adding a new Fetus system block, and then also a Fetus component block. Here's a list of the different components available from the standard. It's similar to most of the other reliability prediction standards. One thing that it does have is commercial off-the-shelf function components. This was something that was important when they were creating it, because the MIL Handbook 217F was becoming increasingly pessimistic for COTS, commercial off-the-shelf components. So the Fetus standard, they wanted to incorporate those and have it, because those are now very widely used, even in military applications. So they wanted the ability to accurately and correctly model those. Okay. Just to give you an idea of some of the parameters that go into the Fetus standard, they're, again, similar in many ways to those that you might see in the MIL 217, MIL Handbook 217, where you have component qualities, the style of the components, the voltage, the operating and rated voltage, a few other common parameters like that. One thing that has been expanded specifically for the implementation of the Fetus standard is the phasing features of the Reliability Workbench. Let me just jump over to Reliability Workbench 12 right now. You may have seen, if you use the prediction standards, you might remember the phases options that you could set in Reliability Workbench 12. That's what I have open right now. So if you went to the project options, you could set up to 10 phases. And then for each phase, you could specify a duration, how long did the phase last, and then environments for each phase, and then temperature. What was the temperature for each phase? This way it allowed you to model the whole system lifetime of, for instance, a component that was used on a rocket. Where it's sitting on the ground in the launch tube, it has a certain temperature and a certain stress, then during launch and then during flight. It's different during all these periods, so it allowed you to model the length and the temperature for each one of these phases, and it would come up with an average failure rate over that, over the lifetime of the use of that component. So that was from version 12. With the implementation of Fetus, we've expanded that those phasing options. So let me go up into the project. Now we now have this process phases tab. Rather than having a set hard-coded 10 phases, you can actually specify an arbitrary number of phases. There's just an option to add a phase. For each phase, you can add similar measures, how long it lasts, the temperature, but also additional things, the temperature cycling, the relative humidity, and various other parameters, primarily having to do with the FIDE standard. So you can see my some of these parameters that can be set. So this way I can add multiple phases. And this again ties into the FIDE standard. If I close that and go back to that component I had added, there's an option where you can go to phase parameters, and you can set certain things, depending on your component type, based on the phase. So for each phase, I didn't name the phase in this case, but you can actually name the phases now. You can specify, for instance, an operating voltage for each phase for a capacitor. Depending on the component category that you're using in FIDEs, you might have different parameters that you can set by phase. Here it's just voltage. Others you might set the temperature by phase, or the relative humidity, or whatever is relevant to that component type that you're using. So that's another one of the upgrades that has been made to the software. So you might have noticed that I'll just point out some of the other options that have been changed in the project options for the prediction. So we have the phases, the process/phases now. We also have the ruggedizing option as well. And again, I think this also ties into the phases where you can, or to the FIDE standard, where you can set various properties for doing the ruggedizing analysis. Again, I'm not sure. Again, remember, Isograph is a global organization, so we have users all over the world. I don't know how. I'm not familiar with the FIDE standard because it's hasn't really come up with many of my clients. So I'm not sure if anyone else is using this in the United States. It is a French standard, so I have the feeling it's probably more commonly used in Europe. But I know that we have some clients who have branches all over the world, so they might be more familiar with FIDE, so they can use it here in the States. Are there any questions on that so far, Jeremy?
No, not so far.
Okay. Okay, going down the list of upgrades, in addition to the addition of the FIDE standard, another, well, it's not a reliability prediction standard, but another update we made is with the NPRD library. You might be familiar with the Non-Electronic Parts Reliability Database. It's, again, another publication of the Reliability Information Analysis Center. NPRD, well, the latest edition of that is NPRD 2016, the latest edition of their failure rates library. Now, NPRD, jump over the parts library, NPRD is just a list of different component types, non-electronic parts. There's a whole lot of them. There's several thousand categories of non-electronic parts. And what the Reliability Information Analysis Center has done is just collected information on various different parts and how they were used and how many failures occurred, and basically come up with a way of estimating the failure rate for all these different types of parts. So now in the Reliability Workbench 13, we've incorporated the latest edition of NPRD, NPRD 2016, so it has the latest failure rates information. However, we took it a step further than we have in previous versions. And the NPRD 2016 also is related to what's called the FMD 2016 library. FMD is for failure modes. So NPRD includes the failure rates, but FMD also includes failure modes for those component types. Now that ties in more specifically to use in the FMICA module. So open up that parts library. So our NPRD library, instead of just including failure rates, also includes the failure modes for certain component types. So for instance, I choose one of my component types, and I drag and drop it into the FMICA. Drag it and drop it from the NPRD library. You can see it actually created, for this component type that I took out of the NPRD library, it also now created failure modes complete with apportionments. The alpha value is the apportionment, or the percentage of failures that are due to that particular failure mode. So this actually, this is a frequent question, is that do you have a library, a failure mode library? In the past, the answer was unfortunately no, we don't. But now we can say yes, we do via the NPRD, or rather the FMD 2016 library. We can now have a library of failure modes for different component types. And again, as usual, the NPRD can be used basically with any of the modules, with the prediction, the FMICA, the RMD, and the fault tree. You can drag and drop a part into any of those modules, and it will create a block or a failure model in the fault tree using that failure rate. The FMD just also now adds the addition of failure modes for use with FMICA. Another new feature with the NPRD library, or with the parts libraries generally speaking, is the parts libraries are now a separate download. What was happening was they were getting larger and larger, and they were increasing the install size of the program. So the 64-bit version of Reliability Workbench 12, I think, was something like a 400 megabyte download, and most of that was honestly just the parts library. So we've removed the parts library from that installation, the default installation. That way, if you're not using the parts library, the installer is a much more manageable size now, just about 100 megabytes for the 64-bit version of Reliability Workbench version 13. You can still download the parts library from the customer area of our website. So if you have a license for it, you can download it. And the website gives instructions. It's actually very simple. You just place it on a directory on your computer, and there's in the application options, you can set where the location of the parts library database should be. Oops, I just set that location right here. If you do not have the library, or you have not downloaded it, there's actually a demonstration version of it that's now installed with the software. So when you install Reliability Workbench 13, it does have a small, it's just the first component in each category. So it gives you an idea of what sort of information is kept in the electronic parts, in the IAEA and the NPRD. Before the parts library was locked away, so you couldn't really see it unless you had a license for it. Now you can see at least the first component in each category, so you can sort of get a trial or a view of it, so you can sort of get an idea of what information is entered and if it might be useful for you. Jeremy, any questions on the libraries?
No, those of you asking for additional information pricing, I'll send that after the web meeting.
Sure, okay. Okay, next change that we can cover, that I can mention, is let's go over to the fault tree module. I know I think probably most of our users are fault tree users, so this is probably relevant to most of our users. The fault tree hasn't seen too many upgrades. There's a few behind the scenes things that would speed up calculations or make it run more efficiently in certain circumstances, or a couple bug fixes for relatively obscure bugs. There's one really odd display bug that we encountered with one user that's been corrected. But there are also a couple new features that I think some of you might like. I know a few users have specifically requested this one. So if you've used the library facility, you know that you can open an existing fault tree project as a library. So if I go to File, Attach Library, I can find any of my fault tree projects, let's take my cooling system, and copy data from that project, from that library, into my project file. And that's one of the major ways you can share data between project files. So you're starting a new project and you want to base it or build it up from information stored in an existing project. So you open up that existing project as a library, and then you can drag and drop data out of it. Further to that, you might have also known about the data linking facility. Data linking allows you to link the failure mode, or excuse me, the failure model from one project to that from another project. Data linking means that if that project changes, if the the library changes, the failure rate for that failure model changes, you can easily propagate that change to the projects that draw from that library. This is most commonly used when you might create a project, or rather a library, that's just a list of failure models, all the different types of components that you ever use. Put them in one project, have all their failure rates, so you have one centralized location for failure model data, or for failure rates. And then whenever you build up a new project, you draw from that library. When your central source changes, when you put in new failure rates, you can easily update using the edit menu, transfer linked data. You can easily update data links from that library. Okay, so many of you may have used that functionality. And lastly, some of you may have been aware of the functionality. If I go to the project options on the data links tab, there is this assign data link when downloading generic failure models option. And what that meant is when you copied a failure model from the library into your project, it automatically created the data link from this failure model in my project back to the library. So you can see my data link is active. It tells us linking to this project. Here's my source project and the source object type. And this way, if I ever change this project, this cooling fault tree, you can see that it's data linked, and it will show me whether or not the information is up to date. If the library is changed or the failure rate is changed, I can easily transfer that changed data into my project. So far, so good. I think a number of users have used this feature before. There was one thing that had been requested, though, that the software did not do. In version 12 and previous, that data link was only automatically created when you copied the failure model directly. If I copied a generic failure data model, it created the data link. It did not create it if you copied the fault tree structure. So if I grabbed a branch of my fault tree and dragged it across, it would copy the generic failure models, but it would not create a data link. So this has been improved in Reliability Workbench version 13. If I take a fault tree and copy it across from my library into my project, okay, as before, it copies all the child or the dependent data, so all the events got dragged across. It created failure models, but now, instead of just creating the failure models, it also data linked them as well. You know, this was a feature that specifically asked for by a number of users, because they didn't want to have to manually copy each failure model and then also manually copy the branches of the fault tree. So now those data links are created for generic data, even when you copy the fault tree structure. That's just a quality of life improvement for those using the library facility. Okay. Let's see, what else can I mention? A couple other fault tree improvements that I will mention. I'm not really set up. I didn't create the projects to really demonstrate these features, but I can at least mention them, what they are and what they do. You may have used the special sensitivity analysis in the past. Just if you're not familiar with what that is, actually, let me. I have another copy of Reliability Workbench 12. Let me open up my fault tree cooling system. Okay. So you may be familiar with the results are out of date. Let me run them first. The special sensitivity analysis basically gave you a way of varying basic event parameters to see the effect on the gate. So it was most commonly used for adjusting test intervals. What happens if I test more or less often? How does that improve my system performance, my system unavailability? It could also be used for adjusting failure rates or mean time to repair. So if I could repair it faster, or if I kept the spare parts on hand so that we didn't have much downtime while waiting for repair, how would that improve our unavailability? So it was very useful for that. And a number of users used it for that reason, to figure out how changing a basic event parameter would affect the gate. The one drawback to it was if you were doing a safety instrumented function sort of analysis, a SIL style or a 61508 style safety analysis, very often you're working with dormant models, And for the highest accuracy, you're probably using the IEC 61508 method of dormant failure model calculation. Now, due to the way the special sensitivity analysis worked, it had to do a lot of different, had to solve the fault tree many times. So it used sort of abbreviated calculations. And those calculations didn't really play nicely with the 61508 dormant failure model calculation. As a result, the results didn't often make sense. Usually what you would just have to do is flip it to the mean dormant failure model calculation, which was okay. It would give you a results comparison, so you could sort of get an idea of how much better or worse it could be. But it was kind of an annoyance that you had to turn or change the dormant failure model calculation, and if you didn't know that you had to do that, you might have run into trouble. Well, now with Reliability Workbench 13, we've improved that special sensitivity analysis to be able to, so that you can use the 61508 dormancy averaging with a special sensitivity analysis. So you don't have to worry about changing this calculation option just to perform the special sensitivity analysis. So that's again another quality of life improvement for the users who are performing that sort of style of analysis. Also on the subject of the 61508, this case with the IEC 61508 failure model, we've extended it to allow you to calculate high-demand system frequencies, excluding dangerous detected failures. So you can, when it calculates the failure frequency, you can tell it to exclude the dangerous detected failures. And that was for those cases where basically dangerous detected failures don't affect or you're not interested in its impact on failure frequency, dangerous failure frequency, because a dangerous detected failure, you know about it, so it doesn't usually incur the negative effects, or the negative downtime. So you might want to exclude it in those cases. So there's now an option for that. Okay. Before I continue, Jeremy, any other questions?
No, nothing that we need to bring up.
Okay. Let's see. There's a number of other quality of life and just small, useful improvements that have been made. I'll just highlight a few of them. One is in the grid view. I don't know if you use the grid view. I use the grid view a lot. It's one of my favorite things to use. I find it very helpful when you're editing, when you're making lots of edits to a fault tree. You get this tabular layout, so you can just directly type in text, enter it directly into here. I find that very useful. Again, it's not just the fault tree module. The grid view appears in all of the different modules. Anyway, the grid layout options dialog has a nice little improvement now. Right now, the columns where you choose which columns are visible and hidden in the grid, right now it's going by the column description. That's not normally an issue or a problem, except it could be a problem when it came to the notes fields. It's showing the note field description and not necessarily the note field name. Well, we've now added a tooltip. So when you hover over, you can see next to my mouse cursor, I hope it shows in the on your end. When I hover my mouse cursor over one of the fields, it shows the column ID. So you can see this date is notes 8. The detection method is notes 4. So it makes it a little easier to relate the field or the column description that's shown here to the column ID. The reason that becomes an issue, if you ever use the import, then the import is always based on column ID. So it'll ask you to match to, for instance, notes 1 through notes 8 fields. Here it's going by column description. So that's just, again, another quality of life that makes it a little easier to understand what each of these columns represents. Another little nice feature that's been updated. Let me switch back to my other instance. And I'll add a new top cake here. For the, let me see, which one is it? Is the Weibull? Yeah, the Weibull model, Weibull failure model in the fault tree. If you've, the default option, is that when you add a failure model to a basic event, the failure parameters are displayed underneath the basic events. So we've expanded that so that the characteristic lifetime, the ADA parameter, is only displayed if non-zero, but more specifically, the beta parameter, the shape, is also displayed underneath the basic events. So now it says ADA 1 and beta equal to 1. Before, the beta parameter was not displayed. Beta is now displayed underneath the basic event when you're using the Weibull model. Oh, there was one more thing on the data link that I did not mention on that data linking where I could copy back and forth. Using data form to assign a data link between two objects now copies the source description, target description blank. Okay. Basically what that means, I haven't really tested this out, so I'm not sure exactly if I can get this to work. If I create a data link between this failure model and something else, let's go to, let's link it to this, actually it's not going to work. Let me go to the external project, to the library. If I data link it to this library, and I link it to a particular failure model, let's say the CB dorm failure model, it also copied the description. Because my description here was blank for this failure model, it's now copying descriptions in the data linking. So if you want the, your generic, or your library of generic failures, all your different failure models, all your different components, you can assign descriptions to them, and then when you data link to them using this data link form, it copies the descriptions across as well. That's again another quality of life improvement. A lot of the rest of it, you can look through the new features, that little handout that Jeremy provided, and you can look through the rest of them. A lot of them are just minor tweaks, minor fixes. Text quality for print preview diagrams is improved. Or during import, you can match an integer field to a double length floating point field on import. Various minor things like that, which aren't, I can't really show exactly without spending a lot of time setting up a project. But you can sort of get an idea of some of the minor tweaks that I've made. And again, that feature is just the new features. If you do download it from the customer area of our website, I'm not sure if Jeremy has instructions for how to do that. Later on, you can just download the new version. If you go to the customer area, in addition to the new features, you'll also see a version log. The version log is a complete list of all the bug fixes as well. So you can see from version 12 to version 13, every single bug fix that's been made as well. So that might also be of interest to see. Again, I don't know if Jeremy, if you're going to get into it, but again, he did mention that if you do upgrade, you do need a new license. So if you want to upgrade from version 11 to 13 or version 12 to 13, let us know. Just email Jeremy or myself, and we can provide you with a new license for version 13, so long as your maintenance contract is up to date. Jeremy, is there anything else you'd like me to go over to cover?
No, I think that's good. If as you begin to use version 13, please feel free to call us if you have any questions or need information on calculations, things like that. But that stands true no matter what version you're using. But if so for those of you that asked questions that well, there weren't a lot of questions, to be honest, so I guess we did a pretty good job. If you think of questions later, just let us know. Otherwise, thanks for attending today's webinar. Thanks, Joe.
Thank you.